Section 7.3 talks about integrations of trigonometric functions. So we know that the derivative of sine is cosine. So the integral of cosine is the sine. We know the derivative of cosine is negative the sine of x. So when I want to go backwards, I'm really thinking, what do you take a derivative of to get sine? That must be in the negative cosine plus c. So you got to be careful with the negatives, that's all. So the first six are our traditional, we know that. Derivative of tangent is secant squared, derivative of cotangent, negative cosecant squared, derivative of secant, secant tangent, derivative of cosecant, negative cosecant cotangent. So those we've been playing with for a while now, we are hopefully accustomed to and are comfortable with. The two new ones that we're not used to, and we'll just keep on adding to the pile, the integral of tangent. If I want to figure out what the integral of tangent of x is dx, I would say that is the integral of sine of x over cosine of x dx. And u sub, I would let u equal the denominator of a fraction, if you remember. Then the u will be negative the sine of x dx. So off by a constant, not a problem. And if you recall how this works, this would be what? This would give me negative natural log of u plus c. That is negative natural log, and my u was, if you recall, it's, oops, the cover didn't register, here we go. The cosine of x, it's right there. Now, this is fine, but sometimes you could take the negative and make it a power. And natural log of 1 over cosine of x, and 1 over cosine is secant of x. So this book seems to use this more, but other books stick with this. It doesn't really matter. Either way, it's the same thing. So the integral of tangent is natural log of absolute value of secant of x plus c. The integral of cotangent is negative that. Negative, and instead of secant, it's cosecant. Easy to remember. Now, we have another one to derive. So you deriving this is a lot of work. It's worth memorizing. We want to get this out of the way. If I want to integrate the secant, and the reason we're really focusing on those, they come up a lot in our applications and what's to come. Now, integral of secant is very hard to do, and don't ask me how somebody figured out they're going to multiply by 1. That's allowed in math. And the one they're going to multiply with would be secant of x plus tan of x over itself, assuming that doesn't equal 0. So somebody said if you multiply by this one, you're going to get secant squared of x plus tangent plus secant tangent over secant of x plus tan of x. Why would they do that? Because then they realized that if you let u equal the tradition, the denominator, can you guess what du will be? What's the derivative of secant? Isn't that secant of x tan of x? What's the derivative of tangent? Secant squared of x dx. And did you notice that secant squared of x plus secant of x tan of x, secant squared of x plus secant of x is simply du. So whoever did this figured out that this is the integral of u, and that's simply du. That's simple. Now, of course, this is before TVs and before cell phones and online and all of that. Probably they had to think about this for a long time, and they figured out a lot of things, unlike today. Today, something totally different. But what's u? U was secant of x tan of x plus secant squared of x. Now, again, the reason we're bringing this up, if you get that out of the way, then the cosecant will be cosecant cotangent with a minus. The reason this is coming up, later on in the sections, you're going to be doing a problem, and out of nowhere, you need to integrate one of those. And you can't just stop there and say, you know what, wait a minute, what is that? Let me derive it. You're not going to do all of this work. So you could have this. I am going to give you some of those on your exam to use, but for now, let's try and figure a way of remembering those. Now, it would be sufficient to remember those two. So I'm looking at the first problem, and I notice there's a 5 there. Well, let's see. If I let u equal the angle, du is 5 dx. So this is my u. This becomes the integral of the sine of u. And dx is actually the du and a 1/5. So this is 1/5, and now you got to remember, what do you take a derivative of to get a sine? Negative cosine of u plus c. So this is negative 1/5, the cosine of what? What's my u? My u was 5x. Now, instead of doing this, and something that's gonna always come up, instead of doing this, couldn't have I said, you know what, only if this is linear to the power of 1. Couldn't have I said, what do you take a derivative of to get sine? Negative cosine, actually right there, straight right next to it. Here, let me resize this. There we go. So this is one way of doing the problem. But couldn't have I said, look, what do you take a derivative of to get sine? Negative cosine, if that's linear. When you take a derivative, you multiply by the 5. When you take an antiderivative, you undo the multiplication, which is division, and save myself all of these steps. For example, when I look at b, I'm going to do it both ways. One way is for me to look at this and say, wait a minute, this is cosecant, it's right there. This is going to be natural log of cosecant of 3x minus cotangent of 3x plus c. If I take a derivative, I multiply by the 3. If I take an antiderivative, I divide by the 3. I'm done. Or, of course, you are welcome to say, look, let u equal 3x. du is 3 dx. So the dx is really du over 3. This becomes the integral with a 1/3 of the cosecant of u du. And here's my substitution. Oops, it didn't register again. Here's my substitution. And that is 1/3. And wouldn't this be natural log of cosecant of u minus cotangent of u plus c. And I do know what u is, right? U would be the 3x, and that would be 3x. So secant is natural log of secant of 3x plus tangent of 3x plus c. Again, if I was taking a derivative, I would have to multiply by the 3. Since I'm taking an antiderivative, by the way, I would divide by the 3. You could write 1/3, or you could put the whole thing over 3. That's really the same thing. In part D, well, this is not linear. Again, you do this enough times, you'll start seeing it. Let's assume you're going to take your time, and there's nothing wrong with that. So normally I let u equal, if you remember, the argument, which is the angle, the argument of a trig function, argument of a log. So we let u equal e to the x. du is e to the x dx. So I notice this right here is this right here. So there's my du. And this becomes the tangent of u. And now if I look up there, that's going to be natural log of absolute value of secant of x, or negative natural log of absolute value of cosine of x. Now I gotta tell you, this book seems to like this notation a bit more, but most books I've used use this notation, so it doesn't matter. I'm gonna say this is natural log of absolute value of secant of x. And if I substitute back what u was, there it is. Now, in the back of the book, there's a very high chance that you find this as negative natural log of absolute value of cosine. Just remember that that's the same thing. And when I get to e, again, what do I let u equal? The angle, the argument, or the denominator. If I let u equal the square root of x, du is 1 over twice radical x dx. It seems if I let u equal this, I know it's kind of confusing because there's a radical on the bottom, but do keep in mind that matches this piece. So this becomes the integral, and I'll color code those. Cosecant of u, cotangent of u, du with a 2. So that took the place of dx over radical x, and there's my u. And what do you take a derivative of to get cosecant cotangent? Well, isn't it negative cosecant of u? Because derivative of cosecant is negative cosecant cotangent. And all what you have to do is replace this by u. So sometimes it's easy to see what u was, and sometimes you need the substitution. It really doesn't matter. Substitution takes an extra step or two. If it's linear, I could get around it, but if not, then this is probably the best way. How about this problem? Well, I notice here that it doesn't look as straightforward as I want. I'm going to let u equal, remember, the argument. Du is 2x dx. Maybe I should make that look, it might be not as clear. I'm sorry. Here. Just one sec. There, I think now it looks better. Well, this is going to be the integral, and I notice that's my u, so that's going to be secant of u, tangent of u, and x times dx would be a du and a half. That is 1/2, and now the question is, what do you take a derivative of to get secant tangent? Well, we know it's secant of u, so that is 1/2 the secant, and we know what u is. And there it is. 3 more to go. If I look at this problem, well, the u sub doesn't work. If I let u equal 1 plus cosecant of x, that wouldn't work because du wouldn't be dx. So since that's not working, if that's a 2, I'll FOIL 1 plus twice cosecant of x plus cosecant, wrong page, forgive me, plus cosecant squared of x all dx. So this is x plus twice. Remember, secant is natural log of secant tangent. Cosecant is cosecant minus cotangent, not plus. And you could look at the table up there. And what do you take a derivative of to get cosecant squared? Derivative of cotangent is negative cosecant squared, so that's actually a minus cotangent of x plus c. The c is very important. Don't forget about that. I'm going to shift this a bit to the right. How about that example H? In example H, if I let u equal the denominator 1 plus tangent of x, du is derivative of tangent is secant squared of x dx. So this becomes the integral of, and let's see how this works. There's my u. There's my du. So u happens to be 1 plus tan of x. Du is secant squared of x dx. Hey, what do you know? That's natural log of absolute value of u. And we know what u is. U is 1 plus tangent of x. And there it is. And as for the last example, again, what do you let u equal? We let u equal the denominator of a fraction. That's the habit. Du is negative sine of x dx. Now, of course, you might be wondering, what if I let u equal the denominator of a fraction and it doesn't work? Well, that's coming up. This is the first technique of an equation. Remember, I said there are 5 altogether. Sine of x dx is off by a negative du. And again, that's negative natural log of absolute value of u. And u was, if you remember, 1 plus cosine of x. And that's pretty much it for this part.